Hi everyone, good morning and welcome to our learning activity video on Senior High School Statistics and Probability Quarter 3, Week 1, B. For the objectives, the learner finds the possible values of a random variable. We move on to exercise number 1. Suppose 3 coins are tossed and let capital letter Y be the random variable representing the number of tails that occur. Find the values of the random variable Y. Here are the 3 coins for example. This is the head of the coin and its corresponding tail. This is a 10 Philippine peso coin. And another coin representing the second coin to be tossed. These are just examples. This is a 5 peso coin. This is its head. And this is its tail. And another coin, the third coin is the 1 peso coin. This is the head. And this is the tail of the 1 peso coin. So we call it head for these 3 coins here, the 10 pesos, the 5 pesos, and the 1 peso coin, and its corresponding tails. Note, in determining the number of possible elements in the sample space of our random variable Y, we use the formula 2 raised to n. It's always a power of 2 because it's either, when we toss the coin, it's gonna be either head or a tail. And here is the number of coin tosses. In this case, since we have 3 coins to be tossed, then we expect to have 2 raised to 3 or 2 times 2 times 2, and that's 8. We expect to have 8 elements in the sample space of the random variable Y. And this Y is the random variable representing the number of tails that occur. This particular part of the learning activity video is very important for you, the concepts and how to make or how to generate the elements in a sample space of a certain experiment. So please listen carefully, and I hope that you put your heart and mind in understanding this kind of learning activity video. Moving on, we let H represent the head and T be the tail of each coin. And we have here the first toss, the second toss, and the third toss. As you can see in the example in the earlier slides, there are 3 coins. So let's start with the tail. So if in the first toss of the 10 peso coin, it landed on a tail. And there are 2 possibilities for the second toss or for the second coin to be tossed. Say for example, a 5 peso coin. These are the possibilities. Let me have it here. Okay, let me have that first. So say for example, in the first toss, we have a tail. In the second toss, there are 2 possibilities, the tail or the head. And then, once on the first toss, we have a tail. On the second toss, we have a tail. On the third toss, you have 2 possibilities. It could be either tail or a head, or T or H. So we're done with this part. Then what if the first toss is a tail, the second is the head, and on the third toss, there will be 2 possibilities. It could be T or H. Another is when we have a head on the first toss, then a tail on the second toss, then the third toss could be either tail or head. And another possibility, a head on the first, an H on the second still, and a tail or a T on the third toss. Then we have the H. If we count the number of possibilities, we have the T, 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 that's 1. T, T, H, that's 2. T, H, T, that's the third possibility or the third element, T, H, H. the fourth, and so on and so forth. So in this experiment, we have 1, 2, 3, 4, 5, 6, 7, 8. 8 elements in the sample space. But that is not the variable y. That is the sample space of the random variable in an experiment. So completing the table below. So let's complete the table. In your learning activity sheet, you have there a possible outcome column, possible outcomes, and then we have the value of the random variable y. Take note that the random variable capital Y is defined earlier as the number of tails. So we have to bear that in mind. Let's start. So earlier, what I had discussed, let me proceed first with the slide before. This one. This whole thing is what we call in statistics a diagram, particularly a tree diagram, to know the possibilities of the number of elements in a sample space of an experiment of tossing a coin 3 times. Okay. So you can have 1 coin, then you toss it 3 times, or you can have 3 coins, you toss it all together at one time. You will end up with the same possibilities. Okay. There are 8 combinations, or there are 8 possibilities. Okay. Going back to this table, so we gather all the possibilities on the first toss. Remember, there are 8 possibilities. So how to do it systematically and in an organized way? So there are 8 possibilities. How do we come up with 8? That comes from 2 raised to 3. 2 because we have a possible head or tail that will come out of an experiment of tossing a coin. Why 3? Because we have to toss a coin 3 times, or we have to toss 3 coins at a time. Okay. So 8 divided by 2 is 4. So we have to write 4 t's first. Then, after that, you again write 4h. As you can see in the tree diagram earlier. You can go back to this video, you can rewind it, or you can pass forward if you want. Then, on the second toss, there are 4 possibilities for the tail. Divide the tail. 4 divided by 2, that's 2. So you have to count 2 t's here, and then 2h. Then another 2 t's there, and then another 2h. Then, on the third toss, you can have this 2 divided by 2, that's 1. So, 1 tail, 1 head, 1 tail, 1 head, 1 tail, another tail, I'll just copy and paste, then 1 head, okay, tail, and a head. So, if you notice, there is a pattern. 4 t's, 4h. Then 2 t's, 2h, 2 t's, 2h. Then a t, an h, a t, an h, and so on and so forth. In this case, or in this style of listing the elements in the sample space, you will never miss anyone or any one of the possible element in the sample space. Any one possible element in the sample space. Then we have to get the value of the random variable y. Remember, the random variable y represents the number of tails in a certain element. So in this case, we have 3 tails. The second one, we have to count the number of tails. We have 2 tails. Then the third one, we have again 2 tails. The fourth one, we have 1 tail. Then another 2 tails. Then the 6th one, we have 1 tail. The 7th one, we have another 1 tail. And here we have a 0 tail. So this answers our question that we have to make this table, and you have to write the value of the random variable y, where y represents the number of tails. I hope you understand this learning activity video. So moving on to the next exercise number 2. Number 1, 4 coins are tossed, and let Z be the number of heads that occur. Find the values of the random variable Z. So it is similar to the activity before. So let's start with the solution. And we have to note here, 4 coins are tossed. So we have 2 raised to 4. So we have 16 elements in the sample space of the random variable Z, where Z is representing the number of heads that occur. Here are the possible outcomes. Again, as I mentioned earlier, there are 16 possible outcomes. So 16 divided by 2, that's 8. So you have to write down 8H, and we have to write down 8T. Here in this second column, we have the value of the random variable Z, and Z is representing the number of heads. Later, we will discuss the number of heads. Now, in this case, since we already have 8H, 8 divided by 2, that's 4. So you have, on the second coin tossed, we have 4H and 4T. Okay, and on this case, we have 8T. So 8 divided by 2, we have again 4H and 4T. And on the third coin tossed, we have, let's consider the 4H here, the first 4. So you divide the first 4H by 2. So it's a 2. So meaning it's a combination of 2H, 2T, 2H, 2T, 2H, 2T's, 2H, 2T's, and so on. And then the last one, HT, 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 and so on, as if you are wrapping. Okay, so that completes your possible outcomes in tossing 4 coins. Once you're done with this, then that's the time that you can write the value of the random variable Z. In this case, it's defined to be the number of heads. So in the first outcome, count the number of H, so that's 3. Then in the second outcome, we have 3H, 3H still, then 2H, 3H, 2H, 2H, 1H, 3H's, and then 2H's, 2H's, 1H, then 2H's, 1H, 1H, and 0H. Take note, students or learners, these are very important in how to come up the possible outcomes in an experiment of tossing out coins. I am telling you to take note of this because in the succeeding lesson, we have to get the probability of each of this. So once you're done with the number of possible outcomes and the value of a random variable in that particular possible outcomes, it would be easier for you to determine the probability. Okay? So I'm excited for the next lesson, but let's concentrate on this first. Okay, next. Another one. A shipment of 5 computers containing 2 that are slightly defective. So 2 out of 5 computers shipped are slightly defective. If a retailer receives 3 of these computers at random, list the elements of the sample space S using the letters D and N. D stands for defective and N stands for non-defective computers, respectively. To each sample point, assign a value small x of the random variable capital X, representing the number of computers purchased by the retailer, which is slightly defective. In other words here, our random variable X represents the number of Ds, or the number of slightly defective computers. So for the solution, we let D represent defective and N represent the non-defective. Then we have 3 computers chosen at random. So we have the first computer, the second computer, and the third computer. Do you have or do you notice any similarities as compared to our previous examples? Going back to this video, you can play it again, or if your memory serves you right, then yes, this experiment of the defective and non-defective computers are similar to the tossing of a coin 3 times, or you toss 3 coins at a time. I just change here, instead of writing first toss, I just write first computer, second toss, second computer, and third toss, third computer, and so on. And of course, we have, instead of writing T or H, I wrote here D and N. D stands for slightly defective computer and N stands for non-defective computer. Concentrate on the D. So the first computer chosen by a retailer, for example, is a defective or slightly defective one. Then on the second computer, there is still a possibility that it's gonna be a D. It's still D. And on the third one, well, one of the conditions in the problem, it says that there are only 2 out of 5 computers shifted or shipped are slightly defective. So we cannot have the D on the third computer because it says that in the condition of the problem, we only have 2 slightly defective computers. So the possibility for the third computer is to be non-defective. So there is no D here. Now, if given the first computer is slightly defective, the second computer is non-defective, there's a possible one that another third computer is a slightly defective computer or another one is a non-defective one. So those are the possibilities. We move on. If the first computer is non-defective, the second computer will be slightly defective and the third computer would be slightly defective. We can do that because in this possible outcome, there are only 2 slightly defective computers. Now, another one, given non-defective, slightly defective, non-defective, again, in the third computer. Another one, non-defective, non-defective. So there are 2 possibilities, slightly defective or non-defective. Good for the retailer if the computer she or he has chosen has 3 non-defective ones. It's an advantage for her. But, of course, we cannot deny the possibility that he or she could choose also 2 slightly defective and 1 non-defective. So these are the possibilities and there are only 7 possible outcomes in this kind of experiment with the given condition on the problem. Let's make a table for this. Oh, I made a table similar to the first one and I listed actually 4 D's and 4 N. And I follow the pattern, 2 D's, 2 N, 2 D's, 2 N, and a D, an N, a D, an N, a D, an N, a D, and N, and so on. But take note here that I crush out this one because this is not possible. Okay? Although it's 3 non-defective, 3 slightly defective. Now, for the value of the random variable x, x is the number of slightly defective computers. So, in this case, it's 3. Here, we have 2 D's. Another one, we have 2 D's, 1 D, 2 D's, 1 D, 1 D, and 0 D. Now, there is a note here. This must not be included in the list of possible outcomes. Why? Due to the condition stated in the problem. Again, remember, the problem states that 2 out of 5 computers shipped are slightly defective. So we cannot have this one in a combination or in a possible outcomes. Okay? Because it says that 2 computers are slightly defective. So this is a non-example or a non-possible outcome. I hope you understand this. So we have to go to the enrichment activity. Take note, the enrichment activity is also similar to exercise number 2. But it's just a different problem. See, from a box containing 4 black balls and 2 green balls, 3 balls are drawn in succession, meaning 1 ball after the other. Each ball is placed back in the box before the next draw is made. So once you draw, for example, first draw, black ball, you record it and you return the black ball and draw another one. Let G be a random variable representing the number of green balls that occur. Find the values of the random variable G. Okay, so we have to find the values similar to the 3 coin tosses, and then the defective and the non-defective computers. Okay, so 3 draws are made. Each draw is either black or green ball. Okay, so we have 2 raised to 3, 8 elements in the sample space of the random variable G. But take note that there are 2 green balls. You cannot take 3 capital G or 3 green balls. You cannot draw. There is no possible outcome that you can draw from the box 3 green balls. So meaning we have to abide by the condition of the problem. In the problem, there are only there are only 2 green balls given. So it's impossible for us to draw 3 green balls. So this is the notation in this given problem. So, okay. So, let G represent green ball, capital G for the green ball, and capital B for the black balls drawn. And there should be an S here to make it consistent because there are 2 balls, possible 2 green balls. Okay, for the first draw, the second draw, and the third draw. So, recall again, we have in the coin experiment earlier, we have the first toss, the second toss, and so on. And in the computer experiment, we have the first computer, the second computer, and so on. Here, in this drawing of balls, the green and the black balls, we have the first draw, the second, and the third draws. Okay, so we start with the G, because G represent the green ball, and B represent the black balls. So B, or G and B, okay? If we start with the green ball, then on the second draw, first draw is G, second draw is another G or another green ball. There is no possible green ball on the third draw because there are only 2 green balls. So, we have the third draw is actually the black or black ball. Okay. Given G on the first draw, it could be B on the second draw. Then there are 2 possibilities in the third draw. It could be a green or a black ball. Okay, this is done. We're done with the G. What about if we start with the black balls? So second draw is G, and the third it could be G. So we still satisfy the condition in the problem that there are 2 green balls. Okay, so given the first draw is the black, the second draw is the green ball, and of course possible is on the third draw we have the green earlier and the black ball. Next is given B in the first, B in the second. So what are the 2 possibilities? It could be G or B. Okay. These are the possible outcomes. So take note of this. There are 7, not 8. 7 possible outcomes. Okay. Let's make a table for this. So we have the column for possible outcomes, and we have the value of the random variable G, the number of green balls. So let's concentrate first on the possible outcomes. So there are only 3G and then 4B according to our tree diagram earlier presented. And of course, we cannot have 2 G's here, but 1 G and then 2 B's, 2 G's, 2 B's. And on the third one, we have B, G, B, G, B, G, and finally B. Okay. So we are sure that these 7 possible outcomes are the elements of the sample space in an experiment of drawing a green or a black ball. Value: how many green balls in this particular element, GGB or green, black, there are 2 Gs, 1G, 2Gs, 1G, 1G, 0G. So these are the values of a random variable G in this given experiment. So long for this. Thank you very much for listening. Again, this is Teacher 𝗲𝗲𝗶𝗶 saying, always stay happy, healthy, and safe, and God bless us. Thank you.